I've opened the Rhino file called Desmond and a grasshopper window in that, which we'll come back to later. And hopefully the screen capture is working. So what's happened here? So here's Desmond, and this was from a scan. Jim, do you want to tell everybody what?
Yeah. So yesterday night after your lab, we just did this 3D scan of my face. So this was the thing that came out. When we first did it, it was not that solid, but there was this function that we can actually make it solid. So it seems really fine. Yeah.
Right. So the first thing they scanned was David's foot, and they didn't realize there was this. So obviously there's a whole lot of problems with this mesh. It's just not complete. But they realized later that there's a solid toggle. It just tries to force solid. So the result is that this is a much better format and makes it infinitely easier to do this stuff. Almost nullifies the point of this first part of this tutorial. But let's talk about that. Okay, so for those of you, I guess everybody's pretty much new to Rhino. When you first open it, Rhino may appear in 4 windows like this. Is that the case for people?
Yeah.
So you just double click. I mean, you don't have to, but just the way I work, I always work in just a single 3D viewport. And you just do that by double clicking on this little gray box. Also, if you right click on that, there's some useful stuff. Basically, first just pay attention to these different kinds of viewports. So if I want to go to a rendered mode, for example, I want to see a closer impression of what this might look like fabricated. This is what rendered mode looks like. Yeah, that's something I should have mentioned actually. Having an external mouse is pretty essential. If you don't have an external mouse,
Yeah, you can grab one from any of the computers on the table.
right? I don't even know. You can click this zoom thing.
They don't have enough buttons, but yeah, well, some of them you probably can get a right click.
Right click is good. So right click is orbit, and right click to orbit. Hold Shift and right click to pan. Alt and right click for zoom. What else?
Sorry, I can't even get to this. I don't know how to get to this.
Oh, double clicking here.
Double click this on any gray part or on the
Yeah, so that'll maximize any window that you're looking at. So if you want to focus on the right viewport, which we can do later.
Yeah. Mine's like yellow color. Mine's like.
Oh, that means so it's yellow because you have something selected. So if you just click off of it somewhere, just click on something else.
All right.
There you go.
All right. How do you turn the face again? Like turn the angle, tilt the angle.
Oh, orbit.
Yeah, like how do you do that?
The right mouse button.
Right.
Just hold down the right mouse button.
So if, I don't know if you have it set up. Two fingers on the pad, trackpad will do the right.
Okay.
One finger.
All right. Yeah, looks like this is recording. Okay. Okay, so you guys more or less there? All right. Okay, so then also for just general interface things, I'm not sure what popped up, but I always keep on the right side the layers and the properties menu. Layers are maybe not terribly important because we won't have a huge different hierarchy of things, but properties are really important. And There are basically three ways to execute any command in Rhino. One by typing it into the command line, one by using these drop-down menus, and then others by going to these tabs and finding the icons. I mean, I guess you can also program your own shortcuts, but the point is I try to do everything by the command line. And there's a lot of reasons why that's a good habit to get into. For one, new versions come out and it's really easy to forget where all these icons got hidden. And another thing is, for example, if I want to do an extrude command or whatever, you start typing extrude and then you start to see all these, it'll autocomplete and it'll give you all these different options. And it's a way you can kind of discover new tools that maybe you didn't realize existed in the program. Maybe you find something you didn't realize you were looking for. And also, that's just kind of, my left hand is always on the keyboard and my right hand is always on the mouse, and it's just kind of a faster way to work, especially when you start doing more tedious things. But if you do, if you do prefer to work with Windows, we can look at these mesh tools. That's what we're going to be doing first. So I should explain a little bit about what is Rhino. Primarily it's a NURBS program, which I think did Neil discuss this a little bit? NURBS stands for Non-Uniform Rational B-Splines, and it's just a different way of representing geometry as opposed to a mesh modeler like SketchUp or ZBrush or there's a bunch of mesh modeling programs. And the difference there is meshes are composed exclusively of triangles and quads, so this is a mesh. So what we're doing today mostly is using a NURBS program to work with meshes, which is a bit like playing football on a soccer field, but you can still do it. What Rhino prefers to do is work with NURBS. This is a NURBS curve that I'm drawing here, and it is defined by what are called control points. And NURBS surfaces are the same thing, just in 2 dimensions instead of 1. So you can kind of edit these control points. So when Rhino saves this curve, it's saving basically 4 points in the fact that there's an interpolated curve in between them. Whereas a mesh program won't do that. It'll have to chop this up into segments and have a number of different points kind of describing that at whatever resolution. So NURBS is a way to work with very light, agile models with very specific and detailed topologies. So anyway, here's Desmond, and this is basically what came from the scan. Well, it's not exactly what came from the scan. I scaled it, and so that's kind of the first step. You can scale objects in these 3D printing programs, but it's definitely your best bet to scale things in Rhino and work in real units and not just abstract sizes. One thing I did before I really started with anything, well, anytime you open a new file, you can specify which units to use. You can also click options or type options, and in the Rhino options, check your units. So I'm in millimeters. You have a tolerance that you can adjust. Actually, that's pretty intense tolerance. I can just change that, but that's not really important. And then I'm just going to stay in millimeters because that's kind of my preferred units. Well, the first thing I did was I modeled the working volume to represent like the maximum envelope that we can print within our MakerBot. So this is just for reference, so I can see. And this, even though they give their dimensions in inches, you can still model that just by making a box, just type box. And you can just, Rhino will always kind of either be asking or telling you something in this command line, kind of asking your next move. So it'll ask me for the first corner of the base of the box, and then it's asking, I just click somewhere, anywhere, and it'll start to draw a box around it. Now it's asking for another corner of the base or a length. And here, even though I'm working in millimeters, I can type 6 inches, just like that, and it will automatically convert. So then I can input something that's an inch dimension into a millimeter document. And then it's something like 12 inches long and then 6 inches high. So that's my working volume, just so I have an idea of how much I need to scale things, so I can be working relatively within the building volume, or the available printing volume. This is still pretty big Desmond to be printed, right, if we think about how much time that's going to take. And there's also... I did. I went to Wireframe. Wireframe mode. You can also check out like X-ray mode, or there's some fun ones. Oh, maybe not that. But I usually just use shaded, rendered, and wireframe.
Oh, interesting. Oh, I type box, look at the first corner, and then say done. What if I draw a box?
Yep.
How do you draw the box? Sorry, I didn't get it.
I just typed box,
Box
and then
and
just
box?
yeah,
Box.
and then just follow what it.
It says first corner of it, so you just point at any corner.
Yeah, you can just click anywhere. You can either, so when you're, anytime it's asking for coordinates, basically, it's asking for a start point.
I see.
And you can give it a relative coordinate just by clicking anywhere, or something that snaps to something else. Or you can give it an absolute dimension, right? You can say 0, 0, 0, and that'll be the origin point.
And how do you change the color?
So I put it on a different layer, and so here in my layers menu, I just clicked new layer and made in this type of name for the layer, and then you can change the color, so on and so forth. And then to put an object on a new layer, you select it, and then in the properties window, just drag it to a different layer.
Is this related to Autodesk at all? It looks so much like AutoCAD.
It does look like AutoCAD, but this is what I like about Rhino, is they're the one company that refuses to get bought out by Autodesk. They're completely independent.
Oh, so you left that in, it's just not visible. So you had the working.
Oh yeah, it was in there. The layer was just off. Yeah. They came from similar, like, related developers. I'm not really sure completely on the history, but Rhino's kept its kind of open source-ness to it. Okay, so then the reason I have multiple, I can just turn this layer back off. I don't really need to see the working volume all the time. I just wanted to get a relative idea of what kind of scale I was working at. So I get this little pop-up window just by clicking the middle mouse wheel, which some of you don't have, but then I can quickly go to my shaded or rendered viewports. The middle mouse wheel?
Middle mouse?
Yeah, like the wheel?
Okay.
Yeah. If you click that once,
and you get what?
you get this little pop-up window. It's not super important. I just use it to change basically from rendered to shaded quickly.
The light bulb, not just
Yeah, so the light bulb is what turns layers on and off. Yeah. You can also lock layers and change all kinds of other properties, but that's too much to get into right now. All right, well, this is the resolution at which Desmond came into this file. And I just kind of, it's totally fine. Actually, just as is, you can already take this and print it, actually. You just scale it to the right scale and then send it to print. I mean, you guys could probably point out what would be some issues with if we just sent this to the print in this kind of a dimension. What would be some issues here? Right, like this.
Flatness.
Right.
Or, well, it looks like it's flat, but it's at an angle.
It's an angle. You could rotate it,
Yeah.
but even then, it's not the only problem because really, like, there's cantilevers, little cantilevers all over the place. There's a we'll kind of export this to the Cura software, which is similar to the MakerBot software. It's actually the exact same. It's just what I'm more comfortable with, and we'll see what would happen. I think another good thing to check, anytime you select an object in the properties window, it'll tell you also what kind of an object it is. So in this case, it's a closed mesh, and that's the format that we need to export in STL. We need it to be a closed mesh file. In the properties window, so you just have 2 layer windows open.
I know. I was looking for which is the.
I think that one. Yeah. Yeah.
Okay. I'll take mesh. STL out.
Right, and it even tells us where it came from. So it's a closed mesh. If I select this foot, the really rough one that didn't come in as a solid, it tells me that it's an open mesh. So, I mean, I think you guys already heard already several times that ideally you're supposed to have this watertight closed mesh to send it to 3D print, which is true, but it's not something that's there's all kinds of tolerances involved. It's very possible to print something that's called an open mesh, so don't let it scare you. Don't get worked up over it. I think an important thing to keep in mind is also just don't do too much work. I mean, it's really easy to, working in 3D, to lose track of scale and just to spend like hours cleaning up something that is ultimately non-consequential. Just if you feel like it's good enough, it's probably good enough, and you can just export it to SDL and load it into the printer and see what happens. We can just do that right now, right? Like, we know this is not going to make a good print, but let's just see what would happen if we try to load this into the print software. So in order to do that, I'm going to type export, and going to find an STL file. Where's STL? And SE shoot. And then remember, we can choose binary or ASCII. It doesn't matter. And it'll let us export open objects. In the printing software, again, this is just like what we saw yesterday, but Cura is the Ultimaker open source version of that software, but it should look pretty familiar, right?
Cura, do we download this? Or?
Yeah, you can download it. It's pretty small and it's free. If you just search for Cura. So I would just load this STL file, and it'll kind of snap in there eventually. It's a pretty big, heavy mesh, so there it is. And it's in 1-to-1 scale, actually. Like, it's still the size that his foot was, which is too big. And we can, again, it's best to scale in Rhino, but we can just do it here, and it automatically puts it back. So we see like there's still all kinds of problems with the mesh, but it's still trying to calculate how to print this thing.
How did you scale?
There's where is it? If you select the object, there's basically 3 things you can do in this program. And it also kind of gives you a footprint of it's kind of a shadow.
So it's everything underneath.
Right.
Part of the product.
And one thing, okay, so one thing that I find really useful in Cura, and there's also a functionality for this in the other software as well, is to, if you click here and go to the view mode layers, this is going to give you, a line-by-line preview of how this print is going to come out. And it's color-coded. So what these, I don't think the other software was color-coded. So we can drag, so this is basically telling me there's 364 layers of printing, and we can kind of drag down and see what happens at each. So if we drag down to the bottom, I'm just trying to make the point of you don't need to be super precise. I mean, what we gave it was a very messy model, and it's not really working here. But for example, here the yellow is a fill, like a complete fill. The red is the outside, and the green inside is kind of an interior border. And then it starts making these meshes. So what it's found is that here we had kind of a closed volume, and then that closed, and then because the mesh was so bad, then for a while it just completely skipped. So if we tried to print this, it wouldn't work. We're missing a lot of information here. But it's still doing its best to calculate some kind of a toolpath. And from here on up, it's actually pretty accurate. Or it's a closed volume. This is something that we could print. And then it kind of caps off and has some more problems there. And all the way up here, it's just thinking, or it doesn't really know what to think. But it'll automatically bound a volume for you if it can. So anyway, my point is it's pretty forgiving, but we still we can't really give it this. All right, so while we're at it, let's just see what do we need to do to get this into something that we can print. And this is something you could spend hours on, and we don't want to, but let's just do it as quickly and quick and dirty as we can. One thing, let's say we want to cut off this, cut him off at the ankle, because this is not really, this is so devoid of information. I mean, it's going to be really tough for us to patch all this in. So I'm just going to make a plane, just by typing plane in Rhino, and just kind of draw something there. And then I'm going to move it up by typing move and selecting vertical. And then I can just kind of find where do I want to trim this thing. So maybe there. And then there's a command called, you type split. Or I'm sorry, it's mesh split backwards. Mesh split. So it asks you to select objects to split. We want to split this. Press enter when done. Enter, and then select cutting objects. So we want to select this as our cutting object. And so what it does is it kind of triangulates at all these intersections, so it makes a denser mesh around this intersection area. And then we can select these two pieces individually and delete this top one. We can delete our working geometry as well.